Welcome back to another episode of the Introductory to C++. Today we're going to look at some source files, some object-oriented samples, and some other good things to help you along your way of learning this good stuff. Okay, quick overview, of course. What we're going to do, we're going to learn how to separate your application into compilation units, because you can't just have everything in one big, huge, this goes off the screen. One big, huge file. It becomes cumbersome, becomes difficult. It's difficult to split it into pieces that you can allocate to different people. So a compilation unit is compiled into an object file, and you link these object files together into an application. Now, each compilation unit generally consists of two files. It doesn't have to be, but generally does. You'll have your header file, which defines the interface to the unit. That's how all the other units know how to call the unit functions and classes. And the source file that defines the actual implementation of the code. Now, one of the advantages of doing this is you can keep your implementation secret. You put that in your source implementation file. It gets compiled into an object file. Now, it's possible for someone to decompile the object file to see what you're doing. Most people won't go through the trouble. So that's why secret's in quotes. But for the most part, no one's going to look at your object file. They're going to say, what are you doing? How are you accomplishing this? And you generally would say, no, we do it well. That's all right. Now, you can change that compilation, the implementation, without having to recompile the other units. You do have to relink them, because now you have a new unit to be linked into the application, but the others don't have to be recompiled. And one thing we have to do with our header files is protect them from being included more than once in the same application, which can cause problems. And we're also going to present some syntax for some object-oriented classes, some prototypes, and class implementation for classes, some virtual base methods, which are very useful for object-oriented, and some polymorphisms we're going to cover today. So, source file separation. So far, everything we've done has been in one big, huge file. It's just for purposes of illustrating how things work. But when you get into the real world, you're not going to be doing things like that. You'll have, this is your piece of the whole application. That will be your file, and you'll have your header file for it. So you're going to need multiple files to put your application together. We need to do that for modularity. So it's, okay, Joe, you work on that. Fred, you work on that. Francine, you work on this piece. So the modules can be modules can be written by others. He says, okay, we're going to buy this module from this company, and they'll send us the object code. We'll incorporate it into our application. So you divide your application into compilation units. In the compilation unit, you can have whatever functions that you're writing that other people are going to use, your classes that you're going to use, constants that you're defining. So your header file defines the interface, and that's public. That's the part that everybody can see. So you'll have a nice big header file that's visible to everybody. And then your source file defines the actual implementation code, and that you can't see. That's a closed eye, if you can tell. The source file will also include the header file, because it needs to make sure that its definitions match the definitions that are public. So you include that into the code that uses it, and then you compile that into an object file that can be linked into an application. So we have a piece to be compiled into a unit. The unit is linked into other units to build a complete application. Here's an example. We're going to have a pair of dice. Singular for dice is die. I hate that word because it's like die. No, it's die. So we have a header file. And I use the naming convention HPP, which is a C++ header file. You can also use .h. Sometimes people use .h++, depending on what you want to do. Eclipse, when you use that IDE, will default to using H. Well, I like HPP because this is supposed to be C++, but it doesn't matter which one of these you use. So my header, my definition for this little function that I'm writing for everybody is roll one die. And die has got the dots on the side, and it will randomly produce a result like you're throwing dice, you're playing craps. Now the source file is called dice CPP, which of course you can't call it .c because that makes it a C file. So that can be C++. Sometimes you'll have .C, but if you're running in a Windows system, case is insensitive, so that causes problems. So just use CPP. It's the easiest one to use. So here's the source file for this particular function. And I'm including the C standard library so I can get the random function. And I'm taking a random, which gives me some number between 0 and some very large number. I'm dividing it by 6 and taking the remainder. That'll give me a value between 0 and 5. Add 1 to it. That gives me a number between 1 and 6. And I'm returning that to the caller. Every time the caller calls this function, they'll get a new random number. And I'll compile this into a .o file, which can be linked into your application. Now, if someone buys this from me, I'll sell it to you for a whole lots of money, and you can use it. You don't know that I'm using the rand function as opposed to, this is the system rand function, as opposed to writing my own random number generator, because I want that algorithm to be secret. But the caller knows this is the interface into my function with whatever comments I may have added to it to explain it, and whatever constants that I may need to define different things. So this is the public part, the header. This is the implementation part, which is kept away and is compiled into an object code. And this is the part that I can recompile this as many times as I want. The other people who use this don't have to recompile their stuff unless I change the header.